Okay, we're now starting our section on solving and graphing inequalities. They're a little bit different than equations. You can see right here I don't have an equal sign there. This is less than or equal to. So these are the type of problems that we'll be doing here for the next few days. I think you can remember there's 4 different types of operators. There's less than or equal to, greater than or equal to, and there's also less than, and there's also greater than. These type of operators here are called closed, and they're signified by a solid circle. Over here, these are called open, and they're signified just by a circle that's not colored in. When you graph these, what you have to look at, so if I have x is greater than or equal to 2, you always look at this point, and this is called your boundary point. And we know that this is a variable. When you have your x on the left-hand side and your number on the right, this always tells you which way to shade. Okay, so for instance, I can see that I have x is less than or equal to 2, so I'm always going to show 0. You always show your boundary point. You show what type of opened or closed circle you have. You can see here that this one's closed. And now because I have the x on the left-hand side, the number on the right, this inequality points the direction that I have to shade. So I will shade to the right. Okay. Now, if this were to change, let me take this and we're going to change this inequality right here. Let's make this less than 2. Then this would now be opened. And because my variable's on the left and my number's on the right, I can use the inequality symbol here, the comparison symbol, to tell me which way I have to shade. This is pointed to the left, so that is the way that I shade. So my shading will be to the left. So these are the type of problems that you'll be involved doing. So you're going to take this inequality here, you're going to come up with a nice simple statement, and from that simple statement you're going to graph your solution. So remember the ideas of open and closed. Remember the idea of the boundary point, and make sure you always show 0. And finally, if you write your statement to where the variable is on the left and the numbers on the right, your inequality will always point the direction by which you need to shade. So now we're going to start our first problem. You do these just like you would an equation. We can see that this term here is on the side that the x term is on, so I want this to go to 0. So it's a -2, so I'm going to add 2 to there, and then I'll add 2 to the other side. So this becomes 0. So now I get a -20 is less than or equal to 5x. Divide each by 5, each side by 5. This turns to 1x, or just x. And then -20 divided by 5 is a -4. Now you can see here that I've got my x on the right hand side and my number on the left, so I'm going to rewrite this. I put x on the left hand side, and I can see that this arrow is pointing to the -4. The inequality is pointing to the -4, so that's the way that I'm going to rewrite it. Now that my variable is on the left and my number is on the right, this helps me with my shading. So now remember, we always want to show 0, and we always want to show our boundary point. If I look at the inequality, it has the bar underneath it, so this is closed. So that means I want to draw my circle and I want to shade it in. The inequality is greater than, I can see that the X is on the left and it's pointing to the right, so that's the way that I want to shade. And now I'll just complete my shading. So there's the graph for number 1. If you would like a couple of minutes or a few seconds to finish copying this down, just have the substitute pause the video. Now we're on equation number 2. You can see it's very similar to equation number 1. This left-hand side is very similar to the right-hand side of the previous inequality. So we've got 5x minus 2 is less than or equal to 18. We can see that this is closed. And we're not going to be completely sure about the shading until we get this thing solved. So a negative 2, take the inverse, so I add 2 to each side. That becomes 0. This becomes 20. So my inequality now is 5x is less than or equal to 20. I want to get the 5 to go to 0, so I'll divide 5 to each side. So now my inequality is x is less than or equal to 4. Erase that, I was going to write 20 again. So it's 4. So now I want to show 0 for my graph, and then I want to show the boundary point. We can see that this is equal to, it has the bar underneath it, so it's closed. So let's draw our circle and color it in. Now that this is on the left, the variable is on the left, and the number's on the right, the inequality points the direction which I need to go. So I need to shade to the left, and I will color that in. So there's the graph for number 2. If you need a minute to copy it down, please ask the substitute to pause the video for just a minute. Okay, this is problem number 3. I have a negative 4 is greater than or equal to 3x plus 5. We can also see that this is also closed. So the boundary point will be a solid point. We have 3x plus 5. This is the term, the constant that I want to get rid of. It's a positive 5, so I take a negative to each side. So I'm going to add a negative 5 there and add a negative 5 there. This gives me a negative 9 is greater than or equal to. This goes to 0. So negative 9 is greater than or equal to 3x. I can see that I need to divide each side by 3 to get the 3 to a 1. So now I have a negative 3 is greater than or equal to 1x or x. Now we see that this is on the right hand side, that is on the left. I don't want it that way. So I'm going to rewrite this. I'm going to put the x to the left, the number to the right, and if we look here, the inequality is pointing towards x. So I'll point the inequality towards x. So there's my rewrite. Now I can see that the x is on the left, the number's on the right, so this will point me towards my shading. The 2 points I want to show is, first I want to show 0. I want to show a negative 3. We've already determined that this is closed, so let me show the closed point. And now if I look at the direction of the inequality on this one, it says I need to shade to the left. So let me shade to my left. And then that completes this problem. So there's number 3. If you need just a second to copy this problem down, please ask the substitute to pause the video. Okay, the next question we have is number 4. It's very similar to number 3. We have 3x plus 5 is less than 8. we can see that this one's a little bit different. This one is opened. You can tell that because there's no equal bar there. There's no equal bar, so it's opened. So it will be a circle and we don't color it in. So this is the constant that's along with the x variables. It's a positive 5. I want to take the inverse to each side, so I add a negative 5 to that side. I add a negative 5 to that side. So this becomes 0 there. So 3x is less than 3. I know 3 divided by 3 is 1, so that'll give me 1x is less than 3 over 3. I've divided by 3 to both sides, so now my final inequality is x is less than 1. I can see my x's on the left-hand side, the numbers on the right, so I don't need to rewrite this one. So now I need to show 0. I need to show 1. Remember that this time it's opened. It's less than. There's no bar underneath it. So I show an open circle. This is telling me that I'm pointing to the left, so that means I shade to the left. So again, remember, anytime the x is on the left-hand side, the number's on the right, you can use your inequality to show you which way to shade. So there's my shading. And there's problem number 4. You can go ahead and ask the substitute to pause the video and finish copying it down if you need to. This is the last question that I'm going to do on this worksheet. That means you have 5, 6, 7, and 8. And 9 is, I think there's 9 to do. So you got 5 problems left for homework that will be due on Thursday. Thank you and have a good afternoon.